Hi everyone. In this video I'll show you some more visuals to help you understand the idea of a sampling distribution. The visuals that I'll show you in this video are a little bit different than the visuals I showed you before, but I think it's helpful to see a concept presented in more than one way. In this video, we'll pretend that this is a small population of 5 people. We're looking at the ages of the 5 people in the population. There's a 20-year-old, a 22-year-old, a 24-year-old, a 26-year-old, and a 28-year-old. We're going to pretend that I'm a researcher who's interested in the mean age of this population. For some reason, I don't have enough time to ask all 5 people for their ages. If I was able to ask all 5 people for their ages, I could just add the 5 ages and divide the total by 5 to get the mean age of the population. But we're pretending that I don't have enough time to ask all 5 people for their ages. So I decide to randomly select a sample of the population and record the ages of my people in my sample, and then calculate the mean of my sample to estimate the mean of the population. When I calculate the mean of my sample mean is going to come out to some number along this number line. I don't know what the sample mean will equal because it depends on what sample I end up getting. Let's imagine that I decide to randomly select a sample of 2 people from this population. I'm going to record the ages of the 2 people in my sample, and then I'm going to calculate the mean age of my sample to estimate the mean age of the entire population. I want you to imagine that when I decide to randomly select a sample of 2 people from this population, the population sorts itself into all possible samples of 2 people, and each possible sample of 2 people is inside one of these boxes. I also want you to imagine that each possible sample of 2 people is placed above its sample mean. So person 1 and person 2 are a possible sample of 2 people, and they have a mean of 21. Person 1 and person 3 are another possible sample, and they have a mean of 22. Person 1 and person 4 and person 2 and person 3 are 2 other possible samples, and they both have a mean of 23. So each possible sample is just placed above its sample mean. Now I want you to imagine that when I randomly select a sample of 2 people from this population, the sample that I select falls down, straight down, and that ends up being my sample mean. It falls down like a gumball from a gumball machine. So maybe I end up selecting person 4 and person 5 as my sample. If I end up selecting these 2 people as my sample, then my sample mean will end up being 27, because the ages of person 4 and person 5 are 26 and 28. If you add those 2 ages and divide the total by 2, the mean comes out to 27. So if I end up getting person 4 and person 5 as my sample, these will be the 2 ages in my data set, and this will be the mean of my data set. And this sample mean will be my estimate of what the mean age of the entire population equals. I want you to realize that since I randomly selected a sample of 2 people, I might have gotten a different sample other than this sample. The sample that I ended up getting depended on chance. Each of these possible samples was equally likely, so I could have ended up selecting any one of them. If I ended up selecting person 2 and person 4 as my sample mean would have been 24, and my sample mean would have been exactly equal to the mean of the population. If I ended up selecting person 1 and person 3 as my sample mean would have ended up being 22, and my sample mean would have been lower than the mean of the population. So right here we're looking at the sampling distribution of all possible samples of 2 people, and my actual sample is just one of those possible samples. Now I want you to imagine that instead of randomly selecting a sample of 2 people, I decide to randomly select a sample of 3 people from the population. When I decide to randomly select a sample of 3 people, the population resorts itself into all possible samples of 3 people, and each possible sample of 3 people is inside of a box. So if I decide to randomly select a sample of 3 people, my sample is going to be one of the possible samples in this sampling distribution. Once again, each possible sample is just placed above its sample mean. Person 1, person 2, and person 3 have a mean of 22, so if you add their 3 ages and divide the total by 3, you would get 22. Person 1, person 2, and person 4 have a mean of 22.7, and these 2 samples both have a mean of 23.3. So once again, each possible sample is just placed above its sample mean. When I randomly select a sample of 3 people from this population, one of the possible samples in this sampling distribution will fall down, and that'll be my sample mean. And the sample that I end up getting depends on chance, because each possible sample is equally likely. Let's say that I end up getting person 1, person 4, and person 5 as my sample. If I end up selecting those 3 people, and I record their 3 ages, then my sample mean will end up being 24.7. Because if you add their 3 ages and divide the total by 3, the answer comes out to 24.7. So if I end up selecting these 3 people as my sample, this will end up being my outcome. Now if I had selected person 1, person 2, and person 4 as my sample, and I recorded their 3 ages, then my sample mean would have been 22.7. And if I had selected person 2, person 4, and person 5 as my sample, and I recorded their 3 ages, then my sample mean would have been 25.3. So I hope these visuals were helpful in helping you understand the idea of a sampling distribution.